this is Leo. Let's do some more Leetcode today. So this is graph valid tree. Let's read the prompts. So we were given a graph of n nodes labeled from 0 to n minus 1. And we're also given an integer n and a list of edges where they indicate there's an undirected edge between nodes AI and BI in the graph. So return true if the edges of the given graph make up a valid tree, and return false otherwise. So it doesn't say that it should be a binary tree. As long as it's a valid tree, is okay. All right. So let's take a look at the example 1. This is not a binary tree. This is a trinary tree. But whatever, it's given us 5 nodes, therefore n equals to 5, and the edges, there are 4 edges here, 0 to 1, 0 to 2, 0 to 3, and 1 to 4. So this makes a valid graph. But in the example 2, let's see, we were also given 5 nodes, and there were 1, 2, 3, 4, 5 edges. In this case, we detected a cycle here. So as we know, a tree structure doesn't contain a cycle. So we will return false in this case. So how are we going to do this? Of course, this is a graph traversal problem. So we need to construct the graph first. Okay. And as for the the graph traversal, we can do BFS, we can do DFS, and also we can do union find, whatever. So for easiest implementation, I chose to use DFS. So for the DFS, we need an adjacency list. So I'm going to put it here. So the adjacency list should look something like this. All right, new array list. Okay. Except for that, we also need a data structure to tell us whether one node has been visited or not. In this case, I've decided to use a hash set, which contains everything. Okay, so I'm going to call it scene, and it's going to be a new hash set. Okay, cool. So once we got the graph, we can traverse from any node since it is undirected. Okay, so we can start from any node. Like we can start from the 0, and when the DFS goes all the way down to 4, and it will go over all of its neighbors. So if the DFS passes, we know that this is a valid tree. Okay? So let's see. First, let's check the edge cases. If in these 2 cases, there were 5 nodes in the 2 examples, but the first one's got 4 edges, where the second one got 5 edges. So if the edges dot length doesn't equal to n minus 1, we can return immediately false, because there must be a cycle in there. Okay, so now we're done with the corner case check. Let's construct the graph. Okay, so first I'm going to iterate every node, and in the adjacency list I'm going to create an empty array list to contain the edges. Okay, so adjacency list dot add new array list integer. Okay, and for Now I have an adjacency list which is empty. I can add edges to it. So for edges, our adjacency list will get edge 0. Oh, sorry, edge 1 and add edge 0. Then we can also get edge 0 and add edge 1. Okay. Now, the graph has been constructed. Now we can do the DFS to check whether there's a, I don't know, cycle in it. Okay. So we can also call the DFS check if graph is cyclic. Okay. So after it, we can return something. Okay. And here we can make the DFS check. Let's name it start. So if a node has been visited before this check, that means there will be a cycle in here. For example, here, if we checked 1, so this node will be marked as visited, and then we visit 2, it will be marked as visited, and we go to 3, it will be marked as visited. Then we go back to 1, which has already been marked as visited. So if this is the case, we can return immediately that there's a cycle in here. Okay, so if scene contains start, we will return. Okay, so now if it doesn't contain, we will add it to our scene hash set, and then we will loop through all the all the neighbors of our current node. So adjacency list .get start contains every neighbor we have, and we're going to iterate through them. Okay, so for the neighbors, we also do the DFS. Okay, and what do we return here? So if we've successfully iterated through all the nodes, everything should be in the hash set. So we just check if the scene.size is equal to n. That should give us the right answer. Okay, let's run the check. Okay, I think it passes. Okay, there you go. Thanks for watching. Happy coding.